All right, clap your hands once if you can hear my voice. Awesome. Good morning. Welcome. It's Tuesday, 10:25 a.m. And let's get ready to rock and roll through DSA. How did our warm-up feel? Yay, nay, okay? What are we thinking? A lot of nays, some yays, most thumbs. I think a lot of us didn't actually do it. Hopefully it wasn't too bad, right? If we remember what a stack is, what's the main rule of a stack? Can somebody let me know? Yeah, pop that hand up. Trey?
First in, first out.
Stack is first in, first down? That's right. Okay, so last in, first down, right? So if we remember a quick review of what a stack is, right? That's like our dishes example. You know, we have like a miscellaneous dishes, right? And we put on a dish. That's the next one to come off. So it's last in, first out. So it's a LIFO or first in, last out. FILO. Right, that's a stack. Do we remember what a queue is? What's its rule?
First in, first out.
Yeah, okay, exactly. So a queue, and what's a real life example of a queue? Yeah, right. We got a little nightclub line, right? We got like that. We got the carpet, and then we've got like this guy here. We have this person, this lady, right? This is a queue, and so that's first in, first out. Unless they have slightly different rules at that club, where like if you're attractive, you get to go in earlier. But then that would be a whole different data structure. I wouldn't know anything about that. Okay. So anyway, so we have our first in, first out. That's our Q. Do we remember some of the methods we have available on these? Yeah, bang. Give me one. Push for.
Wait, for Q or oh, a stack?
Everything.
A stack. So yeah,
Push, pop. What's up? Peak. Oh, I like that. Right? The 3 P's. Is empty. Great. Anything else? Maybe length. Maybe. I don't know, right? Like, we can have tons of functions. Like, right, these are like the ones we have that are like pretty standard to have, but like we could also have reverse, we could also have search, right? Like we could have lots of different actual methods. How about for Q? What do we have for the Q? Who can give me some Q methods? Yeah.
Push, shift.
Not quite. That's going to be for the stack. When we're dealing with Q, those are going to be called Andre. Yeah. So in Q, NQ, and DQ. Right? Remember the old grandmother example? She would DQ. She goes to DQ. She likes blizzards. I don't know if we remember that, but hopefully we do. If I do, you do. Okay, and then we peak. What else do we have? Anything else for our Q? Yeah, we also have is empty. Anything else? Okay, yeah, maybe we have a length, right? Maybe we have reverse Q. Maybe we have search or find or is there or something, right? I mean, point is like these are just like the core, right? Pursuit core of those ones, right? So let's quickly blow one up on to the screen real quick, like the same way as we did last time. And then let's start to make some adjustments. So how could I start this off? Who said what? Yeah. Yeah, right. So we can create this class stack, and we have this constructor. Right. So what we're doing right now, how do we want to build the stack? What do we think? Right. This is the kind of the goal. If I can get the goal across of today, is that I want to emphasize that a data structure is more of this concept that doesn't. Oh man, you don't have to implement a data structure in a set way, right? These data structures are this abstract idea of holding data. Okay, so data structures are abstract, right? So first we can implement this the way we did it last time, which was, what do we have? Can somebody tell me? Chris? Yeah. Okay, so I'm just going to call it like stack or something. And it's an empty array, right? And we did like, I guess we did a length of 0. Or we can probably get the length from, because we have this array, right? But this is using an array. The point that I'm going to make, and then we will see after we go through this, is like, yeah, we can use an array to make a stack. And that's all fine and dandy. But we don't have to use an array, right? We could use a linked list to make a stack. We could use 2 queues to make a stack. So the idea that we have to use an array just isn't the case. We want to stay true to like this abstract idea that the data structure is just a structure and that there's numerous ways of implementation. But let's go ahead, more just fly across. Let's go ahead and finish this one off here. So we look at what we have. We have push. Seems pretty straightforward. Takes in some kind of value, right? And then this is just going to push it, right? This stack push val. What else do we have? We've got pop. So this stack pop, right? And we probably want to return that. Right, this isn't like too wild, hopefully, to anybody. We've got this. Wish I could like remove this 1 inch at the top so we had more. So we've got a class constructor. We're creating this little stack, which is really just an array here that we're using. When we're pushing into that array. When we're popping, right? Because it's last in, first down. So as soon as we push, if we want to pop, should all work. If we want to do peak, what's our peak? Can somebody help me with the peak? Okay, Max.
Just remind me why you don't return the push.
Oh, I'm just adding. We could return something. What do you want to return? The value? Do we want to return the length? What do we want to return?
No, I just saw you return for pop and back as
well. Well, pop has to get something back. Push we're adding in. Maybe we want to return the whole stack. Like,
But for peak, you're returning, well, you're making the last index.
oh yeah, okay, yeah, you're answering that question too. Yeah, exactly, right? So for peak, we want to return that last index. So we say return this stack, and then we can do this. How do I get the last index? A callback from, yeah, everybody. Okay, good, right? We've come a long way. Okay, so right, we've got our push, pop, our peak, our empty. How can we check if it is empty? What's something we could check? Sure. So right, if it's equal to 0, then it's empty. Right. So I mean, this is going to work, and we can interact with it if we want. Right. We could say, right, I can say let st, and we can make a new stack. And then let's start adding some things. Let's add 5. I hate Tyson. Let's add 4. Let's do a pop. We can console log here. We can do console.log. Right, we can check if it's empty right here, because that would make it's right in the beginning. And I'm going to write that again. This is just how I'm going to check everything. Console.log c.peak. Thank you. And then let's just console log the whole thing. Yeah, Davey.
So they're abstract, like what size,
how you can build it.
How to make it?
Yeah.
Well, so, and that's a great question. Like, sometimes in an interview or something, they might decide what type of implementation it will be. So they might say, implement a stack using 2 queues. So then you go, okay. And then you have to figure that out. Another thing is, some of them are more language specific, right? So in JavaScript, our arrays are dynamic, which means they don't have this fixed size, right? We're able to keep pushing and keep pushing and keep pushing and keep pushing, and it's all honky-dory. It's awesome. While in other languages that are a bit more strict, you have to say how big the array is. And so then if you were to implement a stack like that, as soon as our array is full, we'll have to create another instance of an array and repopulate it. And then you do it in double every time, so it's amortized. But a linked list, however, you don't have to specify how long it's going to be, like you do in arrays in those languages. So you can just keep adding to it, and then it's going to work out all right. If we run, we get true, false, 4, and a stack of 5. Yep, that looks good. Right, so it worked. We were pretty successful in writing that stack. Questions on just this quick implementation? Okay. So let's fly through a queue as well. So how could we do a queue? We create a class, right? So it's pretty much the same kind of thing as the last one. Another array, so we'll do this dot queue, and I'll just make it an array. And we've got our methods that we wanted. So instead of push before, we just have enqueue. And we have to now make a decision about the direction we want this array to go, right? If we want to be pushing and shifting, or unshifting and popping, because it has to go like this or like this, right? And either one is fine, it's up to us to implement it. We're in control. So I'll just push. I'll keep it really similar to what the last one was. Push the value. And when we want to DQ, what do we do when we DQ? Yeah, Andre. Yeah, right? We're just going to shift it. So we're going to return this.q.shift. How about peaking? What's peaking look like for the queue? What, David? What's peaking look like? Maybe somebody I haven't heard from yet today. Alex, I haven't heard from you.
It's usually like the first.
How about, yeah, with this implementation?
So it'll be like this Q at 0.
Yeah, exactly. This dot Q at 0. Thank you, Alex. Right. Right, this is going to be the next thing to head off to DQ if it gets hungry. And then we can check is empty. How can we know if this is empty?
that queues are connected.
Yeah, right. So if the length is 0, it's empty. I can just say return this.queue.length equal to 0. Right, and maybe we want a length thing, maybe we don't. But these are the main queues, and I'd say it's going to work. Not too bad, right? Not too painful. Questions on any of this? Okay, cool. So we feel good.
Yeah.
Awesome.
So in this case, we're using the array to do this, but let's say we're using objects, right? In that case, we have to create the whole new function.
So if we wanted to use an object, yeah, you would definitely have to do some different planning. I probably wouldn't suggest using an object because they're not ordered. They're just like key and value. So I think you could, and since queues and stacks are pretty specific in like ordering, I definitely wouldn't recommend using an object. But there's probably a way to do it, but I wouldn't recommend that one. Okay, so let's think about this some more. So, and I think I also asked us to write a node class, right? On the more. Don't worry, it's only like 4 lines. Let's do it. How could we? What do we need for a node? Yeah. Okay, Alex. Let's do it.
Value.
Right. So nodes take in some sort of data, and they also take in a reference to the next thing. Great. So if I said something like class, oh, that should be lowercase. Class node, make a constructor, and so we pass in, when we create a node, we pass in some type of data, and we'll set up this class. So this dot data equals data, and this dot next. What should this default to? What should this? Who said that? Or not? Why?
We didn't create a list yet.
Yeah, sounds great. Yeah, so we're not just, we can default this to null. We don't have a list yet, so there's nothing for it to be pointing to. We can always set up a full linked list and use it that way. Okay. Cool. So this is, there's not too much to this class, right? That's pretty painless. So the question becomes, well, how do we implement a stack using this node? Right, and that's what you're gonna do. All right, so let's take 15 to 20 minutes to try to implement a stack with just making a new stack class and using this node instead of an array. So there'll be no arrays. Questions on the directions?
So now you have available time.
On the node, yeah. But you can add different things inside of your stack. You'll probably need a head or a top. Yep.
It's the singly one, right? It's just,
Okay. These don't have a previous on them, but we shouldn't need it for this one. Good clarifier. Cool. All right. Good luck. Let's implement a stack with a different type of data behind it.
You said make a stack with objects wasn't the best idea.
Is what?
Saying listening, make a stack with objects. That's what I did.
That's like
generally been so you're gonna make a new stack class. Making a new stack class, and every time you're just gonna keep track of that stack, or instead we're reading the array, you'll be taking notes. Data. Yeah. So that's what just go through that last page. Yeah. So like. How we structure where it has this all of them are that's what we're doing.
Okay, how we doing? Thumbs up, thumbs down, thumbs to the side. All right, so let's do it. Let's get us on the right direction and then try again. So for now, I'm going to comment out all of our other stacks and queues stuff. And so right now we only have this class. So we're gonna start this off, right, the exact same way as before, right? We're still making a class and we're still making a stack. Now I was having a pretty good discussion with Renat, and I just want to kind of like talk this over a little bit. Like previously, when we were saying class stack and we had like in our constructor the this dot stack, right? This is just what I was calling it. But this could have been anything. This wasn't really like, this isn't the stack. This is just representing an array in our stack class. And that distinction is pretty important because this isn't really a stack here. I'm using it stack-like, but it's just an array. It's the class itself that is actually the stack. So we don't end up with a stack until when we actually, I might have deleted all that other stuff, until we actually say like, hey, new stack. And that's when we get an instance of the actual stack class. So the array is actually, it's nothing to do with it except for that's inside of the inner workings. So I thought that was a really important distinction that we talked about. So inside of this, we still have our constructor because that's just how our classes work. And so what can we do inside of here? Did any of us have any ideas that we might have come across? Right, so we're not using an array. Davey?
You must make an instance of the node in the stack.
We will be doing that. Probably not here, but that's not a bad guess. Right, so we've got, I guess I can go erase this stuff now. Right, so we've talked about stacks a little bit. So if we're creating this stack, we have like these plates, right? And we always know that when the one comes on, like that's the next one off. So if we think about like lists that we know, like what do we need to know? Alice.
Next, is the head too.
Right, well, we're not even the tail. We only need this head. So if we think about it, every single time we add to the stack, right, we're just making a new head. Every time we're taking off the stack, we're just removing that head and going back to the head.next, right? Head.next or top or whatever you want to call it. So before we've added anything to the stack, we have to figure out what it would be. So if we know this, what do we absolutely need in order to be able to implement a stack? What do we need to know about? I've heard it a couple times. Johnny? Yeah, so we just need to know the head, right? So if we just need to know the head, we say this dot head. And when we've started a stack that's completely empty, what should that value of that head be? No, it shouldn't be next node because we don't even have one node yet. Why? Yeah, so Trey says, well, why don't we just make it null? Because there's absolutely nothing in there. Yeah, yeah, bang. Can I go over what? We're starting with head as null because in a linked list, we can just keep adding things. So if we start with something empty, and then we add a node, and we go, okay, and we call this the head, and then we want to add another node, push to the stack, we can go, okay, we'll add another head, but now this is the head. Because we don't need to see this anymore, because the way the stacks, right, as it first in, last down. right? So then if we wanted another node, it becomes that, and then head, and then every time we pop up, we go pop, we've got our head, pop, we've got our head, and then like up back to an empty stack. That's the movement of the stack. So if we keep that in mind, and this idea, let's attack this again. I think this is a good start for our constructor. And then let's see how we could possibly write, push pop and is empty and peak. Okay. Let's go for another 10 to 15. So it's the head. Right. Oh.
Create no with this data and assign next. And
So whether they're not has to be the same. That's kind of how I visualize That's what I thought set up. It sounds good. No, yeah, I'm just trying to, yeah. But the kind of sound focus. Yeah. Oh, yes.
What?
Especially early on. So I think it's there now. I was like, what? He said, yeah, everybody else ordered sushi. Okay, I'll next time.
Sounds good. Sounds really good. So what? How much? $8, not bad.
Early on, chat. I just want to do different from chat. But like that.
All right, clap your hands once if you can hear my voice. Clap your hands 2 times if you can hear my voice. Yeah, Nikki, question. Oh, okay. Oh, no, yeah, very cool. Like the Bollywood style clap. I like it. Okay. All right. How do we do? Yay, nay. Yeah, this is a weird new idea, right? A lot of us didn't feel that much success with this, and that's okay. Right, we're very stuck in just like how we used to always think that for loops needed an array. We felt like that for so long, a lot of us, and it's no, it just needs a number, right? This is the same thing. We feel like stacks and queues, they need an array, but they really don't. It's just we're just more comfortable with that. But the idea is that a stack is it's just a class that has this very specific behavior with these methods, right? So as long as it has this last in, first out behavior, and you can add and push, and then it's a stack. And that's it. So no matter what you do under the hood, that's a stack. So let's try it, yeah? Let's try to add, yeah, we're gonna use nodes. So we're gonna say, first thing is we're gonna have a push, right? And a push takes in some kind of value. Right, and this should be identical to our previous stack. Now, what happens inside is gonna be slightly different. Alex, you wanna help me with this one?
You could create a new node.
Okay, so we'll say like let new node. And we have to actually create this new node, right? So we say new node, and that's referring to our node class that has data and null. And we're going to pass in this value. Okay. So we've got this new node now. Okay, what's next?
You can make the new node's next reference the head, current head.
Yeah, that's great. So this is going to be the next head, right? This is going to be the head. If we think back to that drawing, we have nothing, and we're going to make a node here. And this is going to be the head. And if we were to add another one, now this is the head, right? So this new node is going to end up the head of our list. But at the same time, if we did have another node in here, we don't want to necessarily lose it. And we currently have head as null. So what Alex is saying is we can say this other, whatever node we just created, we can say that it's next, and we can point it to the current head. That is what you're saying, right? Yeah, Johnny? No, the constructor is done. We have our next and null inside of our node class here. No problem. So we're going to say, all right, so we say new node dot next is equal to this dot head. So now we've just created this node, and we're saying that its next is going to be whatever the head is of the stack. And then we have to make this the head. So we can say this dot head equals new node. Right? Makes questions on that. Okay, so now we've got this push. So let's move on to our next one. Let's say we have pop.
I'm sorry.
Yeah.
So in like logging right now.
In your what?
Like the words running, new stack, include battery, all push. Says data, you get a data point, and put it against the cycle point. That's supposed to be the. Like if we make a stack, where we have push.
If we made a stack? Okay.
And yeah, push 5. Not that. Let's see, so.
Yeah.
Why is the next null?
You're looking at next of the node, right? When we put in our very first, when we started off our stack, our head was null. We created a node and we said, hey, that node's that next is the head. This dot head is null. So that's correct. The next one will point to this one.
So so the whole process of what was going on here is like you save the one previous before you put that.
Mm-hmm. Well, I'm saying like, so if I just assigned this to be the head, I would lose the current head. It would just be gone. So I have to keep track of it somehow. And since I'm making a list, this new nodes.next is going to be what our old head was.
And what's the next one? It's just
That's in our node class. They have data and next
Fair.
attached. With that?
so maybe to help clear that a little bit, it's a little bit redundant. Right? First one, so we do next is going to be next. It's just saying. You could put it like if this head node.next equals this head, otherwise just saving a little bit there. So,
That's what you'll work on.
right, it's just special context of class.
All right. So let's talk about pop. What do we want to do with pop? What can we do? What are we thinking?
Leave the parent home.
Yeah, well, I don't know about delete, but right, we want to return and take off the most recent thing that was pushed in. Right? Can we think of a situation where pop might not work? Yeah, right. So if our head was just null, we would maybe throw an error, or like we have to decide what that behavior is that we want. Do we want it to just return false? Do we want it to just throw the error that it's going to? Maybe we do. I don't. It's kind of like up to you. Maybe we just have it do nothing. Doesn't return anything. Will be really annoying. So we could say if, and we want to check if this dot head, right? So that means is it something that's is it a node, right? Essentially, is it not null? So if we have this dot head, we want to take an item to pop, right? That would be popping off. So we'll say let item to pop, and we'll assign this to this dot head, right? So this is what we're gonna want to return at the end, right? But we're also gonna have to change our head. So if I say something like this dot head, and we say, so this dot head is currently this one node, and its next is for now is null. So we want that, we would say this dot head dot next. What do you mean?
Because we're popping, right? It's because I'm thinking array, packing an array. What do you know?
You might, if you're thinking about it as an array, it is a problem.
In these two examples, we have the two circles. Right? We have
Two circles. Yes.
yeah, so you pop them, say you already
So this is currently the head, and I'm saying that this is going to be the one I'm going to take. Going to take, and I'm saying that this dot head is going to be this one. So this is currently the head. This dot head dot next is this one because it's the next.
you started from the top.
This is currently the head. Points like this. Here.
I thought you assigned the head from the first circle.
Okay.
No.
We created a node here. This is the head, right? We've added another one. This is now the head, which has a reference of in next. Okay, so this is going to be the one to take off. Take off. And we're going to say the head dot next is this one, right? And this is now going to be the head. So we would say this dot head is this dot head dot next.
We can name this as whatever, so I could actually name that this not previous, right? That's what it means. That's what it's kind of like.
So if you're, I definitely wouldn't call it previous unless you want to call this one previous. Is that what you mean? If you call this is referring to the head of our class. This is the top of the stack.
Right. But I'm saying this, previous.
For where?
Or throughout.
If you wanted to make all of these heads say previous, yeah, totally fine. Or not. So if we have 6 nodes, right, we're popping off the most recently added one. Yeah. This. Okay, so we gotta understand how our push is working and how this is happening, right? We're starting off with our head being null. We push a value, we create a new node, and we say, all right, the new node's next is whatever the current head is. So the new node then becomes the head, this time. So this, whatever we keep adding, is always the head, always. So when it's time to pop, since it's the most recent thing added, we have to remove the head. So we say, all right, this is the item we're going to take. The current head is going to be what the head's next was. And then we're going to end up returning our item to pop.data. No, because it's a stack. Exactly. Right. Right, that's the super important idea there. It's like, we don't have to keep track of everything, right? We just have to maintain the functionality of a stack, which is a data structure that has last in, first out. If our class that we create has that functionality, we've succeeded in building the stack, no matter how we do it. Some implementations might be better with memory or better with time efficiency on certain operations, and that's definitely a valid conversation, but it's still a stack at the end of the day. Yeah?
Can you scroll up to the awesome? We're using that code, right?
Yeah, right here.
Yeah.
And all this next stuff is.
So every time we push, we're using that code to create the tail. Because it's
We're creating the next head.
We're creating the next head.
Yep.
Is the head in your drawing? The head is on the top?
Yeah. I'm drawing it like a human. I'm trying to. It doesn't look. Okay, so in my head, it's like this, and it has like the face and arms and legs. But probably not everybody else is seeing that. But now you do. It's a snowman. Okay, so if we want to pop, we've isolated the head. We've reassigned the head to be the next one below the head. And then we just have to return our item to pop. And it's data, right? Because that's what we have in our node class. This is called data. That's the value. Stacked up, we don't want to return a node because stacks don't return nodes, right? We add values and get values back. We don't, I mean, unless our value is a node, which would be fine. But we definitely don't want to, if we don't want to add like a 7 to a stack and then get back this node, we'd go with that is really weird. So instead we'll just do item to pop.data. Okay. And if there isn't a head, I'm just not going to let it do anything. That's going to be my design choice. Feel free to implement yours differently. Yeah.
Can you show the part where it's making the head point to the next node?
Yeah, this part, this dot head is this dot head dot next. No problemo. Okay, that's a problem for Spanish. That's the Spanish lesson for today. Every day, just a little bit. Okay, so then what else do we have on our stack? We have peak. right? And so for our peak, what do we want to return? Yeah, so we want to return the current head and the data inside of that, right? If there is that. So we'll say, because we can't say .data if there isn't. And no, eventually we'll have optional training in JavaScript, and then we'll be able to write this slightly different, which will be nicer. But for now, we can just say if, this dot head, we can return this dot head dot data. Otherwise, let's just return null. Right, so in the event that it's empty, we'll just return null. What else? What else was in our stack before? Do we remember? Sorry? Yeah, we had is empty. Okay. How might we write that? Maybe? So something about checking the head and if it's a null, right? Yeah. So we'll say if this dot head return false. Otherwise, we're just going to return true. Okay. So let's try out our stack. Let's see if we get the exact same behavior that we were hoping for before. So before we created a new stack, and we did console.log, and we said stack dot is empty. Then we did a push. Then we did console.log is empty, and then we did another push. We did push a 4, I think we did, and then we did a pop, and then we console.logged our stack. Right? Does that look familiar? I think those are what we did. Oh, maybe we want to do a peek. Let's do a peek here. Console.log. Thinking about it. Okay, yeah, everything should be fine. Let's try it. Right, so we get it is empty, true, false, 4 on that. That's our peak, and then if we actually just look at the whole stack, it's still just got the one piece of data left, which is the 5, that one node. So it works, right? This is the exact same functionality as what we wrote right in the morning using an array. That's pretty cool. Come on, that's awesome, right? I mean, this is like, no, you don't have to clap. That's ridiculous. But right, I mean, it's just like this is exciting. So the idea, this should really help to drive home this idea that these data structures are these abstract ideas, right, of how something should function and behave, but that the implementation of that is different, and they could have different positives and negatives as far as memory or time constraints or internal functionality, but they still are definitely, they're both stacks. Okay, so now let's do it for Q. Okay, so take the next 15 minutes and try to create a queue. Hint, there's a lot of similarity with stacks, but you'll probably need to keep track of a head and tail.
Since we put back to the push, and these two values are the same when you're making new node and push this,
Which two values?
the value in the parentheses. Push value.
This value and this value?
Yeah.
Yes, identical. I am getting this value from this argument. Good clarifier.
Where each relative has
Is there a way you can push this close to the fire?
Sure. Oh yeah. Yeah.
This is why this console log is like this.
Exactly.
Because we have
Yeah, perfect.
trying to figure out what's the console of both of them together.
Try it. Print it
Yeah.
out. Okay.
I just want to make sure that I was.
Yeah, we'll just say head node data 4 next node data 5 next node. No problem. Yeah, you're definitely on the right track. All right. How we doing? Yay, nay, okay. Okay, let's just kind of get it started in the right path here. I can find my mouse and everything. Okay. So I definitely don't want these. Okay, so I'm building a class, right? I'm going to want to do the exact same beginning. So I'm just going to say class Q. All right, question so far. Okay, and then we're going to have our constructor, right? And we say like constructor. So now we have to figure out like design here, right? So this is a little different, right? We've got to keep track of a little bit more, right? Because for the stack, all we had to keep track of was the head. First in, last out, and then we keep changing the heads out next, and it's like very simple in a sense, but simple, right? But in a queue is going to work slightly different because all of a sudden we've got like this line, right? So you could think of like, we're going to stick something into a queue, we'll say like 7. And then this has to be, currently this is the one we would get rid of, right? And then if I added another thing to the queue, like a 6, this is still the one we have to get rid of because it was the first in. Right? So this is the head. Right? And it's pointing to 6. And if we added another one, it still has to go here. Right? But we need a way to, ideally, we want to easily add in our 5 instead of just going all the way through it every single time. Right? Because that would be really slow. Right? Because if I said like, okay, let's add one to the end of this, and we went, okay, head dot next, then we're good. That's slow. But if we already had access to this, it'd be really easy because then we would just go, oh, okay, here's another one. Right? So for this constructor, what I'm proposing is we keep track of a head and a tail. Okay? So I'm going to say this dot head, that's going to begin as null. This dot tail, and this is going to begin as null. All right, so this is the constructor's done. Okay, so for the next 5 minutes, I know it's not much time, but we've already spent some time, and we got to keep moving. Also, get your whiteboarding. So for the next 5 minutes, setting up your constructor this way. Keep working on, and after also having talked about, like, we're going to be dequeuing the head and then queuing at the tail, but also still adjusting the heads and stuff, possibly for the DQ. So think about that and try to implement, try to refine whatever you've already got written. Okay? All right, let's try it out. Clap your hands once if you can hear my voice. Yeah. Thank you. Okay. So how'd we do on NQ? Yay, nay, okay. Yeah, we got some mediums. That's pretty cool. That's pretty good, right? It's quite a concept to grasp, so that's pretty great that we have mediums. Okay, so NQ, what are some things we want? We're going to start this the same, right? We know we're going to make use of this node class because that's kind of the whole point of this specific exercise. So we can say let new node equal new node, and we pass in the value, right? There. So now, based off of our design here, where we have this head and tail, right? So if there is no head, what do we want to do? There's no head. Yeah, Davey? Exactly. Can you explain why? Because there's no head? Yeah, okay. Yeah. That's a blunt explanation, but I appreciate it. That's all right. That's fair, right? There's no head. When it's time to DQ, we're going to DQ the head. That's what we decided on. So once we NQ, if there's no head, oh, there better be a head by the end of it. So we can say, all right, so if there's no this dot head, then we have to set our head. We have to say this dot head is equal to new node. And we should also set our tail. Okay, so now if we just had 7 here, we have our head and our tail both at 7. Okay? We can pretend that. So if we've got our head and our tail here at 7. So that's in this situation. Now if I wanted to NQ again, let's say, so now it's time to add a 6. I don't care about the head so much. But I do care about this tail. So I'm going to add this thing to attach it to the tail so that it goes, so we forge this connection and create a tail. Okay, so how do we do that? Well, we would say inside of our else here, we could say this dot tail dot next. Right, so when it's just 7, our tails dot next is, according to our node class, is null. Right, we can see that up here. Whenever we instantiate a new node, the next is null, unless assigned otherwise. So down here we can say, all right, well, if this is head and tail, we'll say tail dot next is equal to our node, which is currently the 6. So we say, okay, that sounds good. We can do that. Equal to our node. My hand's one off. Node. Okay, but so as it is right now, let's say we've got this new node of 6. We just created it. It's totally loose. We've got our head and our tail right here, and we want to add this to the end. So we say tail dot next is equal to this. So now we have a point to that. That's what's happening in line 107. Tail dot next is this, but now we want this to also be our tail. So we have to say this dot tail is equal to the node in order to move that so that now we have our tail here. So let's do that. This dot tail equal to our node. Perfect. Right, so that's done. We've added something in. Davey, question? No, I should say, yeah, oh, I wrote new node. I should have stayed consistent. I got spaced. All right. Space down. Good catch. Thank you. All right. Because this is the new node. I got two into the drawing. That's all right. So we set the tails.next, which was originally here, to this one, and then we've reassigned the tail to this one. So now we've got our head and our tail. So if we wanted to do this again, let's try to run it for fun. And I create a new node here, and I say that this is the value 3. And I say, is there no head? No, there is a head. So let's look at our tail, and we say, all right, our tails.next is this new node. So now it points to the 3. But this is now actually our tail, so then we reassign it and say, this dot tail is actually our new node. All right, I'm drawing on a kind of a weird pattern because it's not necessarily like in a line, right? In memory, it could be all over the place. It's just pointing to a specific spot. All right, so let's talk about DQ. Everybody loves DQ, right? Blizzard, they flip it upside down to taunt you right before they give it to you. I hate when they, it's like, just get, anyway. What do we want to do in this? What do we need to happen? What node are we going to be DQing? Head, right? Because this was the first one in. Has to be the first one out. So we got to get rid of the head. So this is only going to work if there is a head. All right, so just like last time, I'm going to say if this dot head. So if there is a head, this is almost the same function as the last time, right? I'm going to keep track of it. I'm going to reassign the head to this one, and then I'm going to return this. Okay, so I'm going to say let item 2 pop, and I'm going to say this dot head. So I'm going to call this here item 2 pop, and then I'm saying that this dot head, and then also on the next line we say this dot head is equal to this dot head dot next. So currently this is our head is 7, and 7 dot next is 6, right? So we say, well, this dot head is going to be this dot head dot next. So now instead of having our head here, our head will be here, right? So we've got our head still, we've got our tail, and then we've got this item to be popped. So let's return that. So let's return item to pop dot data. Right? We still want to return the actual data. We don't want to return the node. And this is of course separate. And then this goes away. All right, so now we have 2 things in our linked list. Pretty cool. Okay, so now we got to work on peak. All right, so what is peak? It's just looking at the head. Exactly, right? Because this is the next one to come out. This is what we're going to show our user. So when they call peak, we're going to say, all right, if there is a head, if there isn't a head, we're going to return, we're just going to do null. But if there is a head, I'm going to return this dot head dot data. Otherwise, I'm just going to return null. Are we okay with that? Right, so I'm peeking, saying like, hey, take a look. Take a look. It's a peek show, right? We're just showing this. Alex.
This head was null. Wouldn't it return null? Even if we just return this head data.
I think it will throw an error because it will say there's no data on null or something. But when we get into optional chaining someday. In which situation? Yeah, I'm saying, he's saying we don't need to check this. We could just return this dot head dot data. And I'm saying you can't do null dot data. I think that will throw an error. Could be mistaken. Optional chaining is coming to JavaScript, which will be really cool. Yeah, Johnny?
How can you have
dot into this, that data.
How did I do that?
Yeah.
Like this.
But like, how's it able to access this?
Hmm.
Parent, child.
So currently our head is this node, and this node has two properties on it. It has next and data. That's coming from our node class. So when we first, that's a great question. So when we first created that node, we passed in the value. And then that value inside of our node class is being passed in as data.
Okay, so every node gets added will give to the
Yep, well, two properties. Yep. Okay, so how do we check if this is empty? What can we do? If there's no head? Yeah, right? So let's just say like, return this dot head equal to null. I think that will work. Right? So let's try. Let's take essentially the same values as we did here. I'm just going to copy these. And this is going to be, let's call it Q. Right? And we say new Q. And so we can say, is Q empty? And then we'll say Q dot NQ, hopefully I spelled that right, 5, and then we'll check if Q is empty. So we'll check if that's working. And then we can say Q dot, let's NQ again, 4, and then we'll check our peak, and then let's DQ, and then let's just console log Q. So we get true, it's empty, false, 5, which is right after we've NQ'd, peak 5 is the next thing to go. And then once we DQ, 5 is removed, and all we have is the 4 that we put in after. So it works. That's great. Cool. So we've got it working. Right? We've got the most basic functionality of a stack and queue working, and we've implemented it with linked list. 0 arrays were involved. That's pretty cool. So in your I'm gonna let you guys go whiteboard. There should be a problem about implementing a queue with 2 stacks. So try to find that problem and do that one. Yeah, Davey, you don't have to solve it yet. Davey's like going into thought. His eyes rolled back in his head like a movie. All right. Okay, so now you will be whiteboard. Thank you. Okay. Thank you. Yeah, of course.